Now we're getting an AWS ElastiCache overview. So the same way RDS is to get a managed relational database, ElastiCache is to get a managed cache, in this case Redis or Memcached. And caches are basically in-memory databases, so they run on RAM and they have really high performance and usually really low latency. And their role is to help reduce the load off of databases by caching data, and so that the read-intensive workloads read from the cache instead of reading from the database. So basically, it also helps make a bunch of applications stateless by storing states in a common cache. And it has a write scaling capability using sharding. It has a read scaling capability using read replicas. It has multi-AZ capability with failover, so just like RDS. And it has AWS taking care of OS maintenance, patching, optimization, setup, configuration, monitoring, failure recovery, and backups. So basically, it looks a lot like RDS, and there's a very good reason. It is pretty much the exact same thing. It's an RDS for caches, and it's called ElastiCache. Okay, that's what you should remember. So there is write scaling, read scaling, and multi-AZ. Now, you may be asking, how does it fit into my solution architecture? And at first I was troubled too, and really this diagram that I created really helps put things into perspective. So when we have our application, it communicates to RDS, as we've seen from before, but we're also going to include an ElastiCache. And so our application will basically first query ElastiCache. And if what we query for is not available, then we'll get it from RDS and store it in ElastiCache. So that's called a cache hit when you get into ElastiCache and it works. So we have an application, it has a cache hit, and we get the data straight from ElastiCache. In that case, the retrieval was super quick, super fast, and RDS did not see a thing. But sometimes our application requests data and it doesn't exist. This way, it's a cache miss. So when we get a cache miss, what needs to happen? Well, our application needs to go ahead and query the database directly. So we'll go ahead and query the DB, and RDS will give us the answer. And our application should be programmed such as it writes back to the cache the results in ElastiCache. And the idea is that if another application or the same application will ask for the same query, well, this time it will be a cache hit. And so that's what a cache does, it just caches data. So the caches will help relieve the load in RDS, usually the read load, definitely. And the cache must also come with an invalidation strategy, but that's up to your application to think about it, so that only the most current data and most relevant data is in your cache. Now, another solution architecture you must have is user session store. And so in this case, our user basically logs into our application, and our application is stateless. So that means there's a bunch of applications running. Maybe they're running into an auto-scaling group. And so all of them need to know that the user is logged in. So the process is such. The user logs into one of the application, and then the application will write the session data into ElastiCache. So this is it. The application, the first one, just wrote the session data into ElastiCache. Now, if the user hits another instance of our application, okay, in our auto-scaling group, for example, then that application needs to know that our user is logged in. And for this, it's going to retrieve the session off of Amazon ElastiCache and say, oh yes, it exists, so the user is logged in. And basically, all the instances can retrieve this data and make sure the user doesn't have to re-authenticate every time. So that's basically another very common solution architecture and pattern with ElastiCache. It is basically, number one, to relieve load of a database, and number two, to share some state, such as the user session store, into a common ground, such as all the applications can be stateless and retrieve and write these sessions in real time. So as I said, ElastiCache can be basically two technologies. It can be Redis or Memcached. And so Redis is definitely going to be the most popular. It is an in-memory key value store, and it is super low latency. So we're talking sub-millisecond, so less than a millisecond latency. The cache can survive the reboots by default. It's called persistence. So not only it's a cache, but if the cache reboots, you don't lose your data, and that's pretty amazing. It's great to host user sessions, as we've seen before. Also leaderboard for gaming, because there's a sorting capability. Distributed states, so again, the user session is a good one. Relief pressure of databases such as RDS, and we saw this in the architecture slide. It also has a PubSub capability for messaging if you want to implement PubSub. And obviously it comes with all the goodies that Amazon gives us, which has multi-AZ with automated failover for disaster recovery if we don't lose the cache data, and support for read replicas. So it's really good for you to know that there is this capability not to lose the data if you have reboots. It's called persistence. And also with a multi-AZ, you can survive service outages. Now, Memcached is a bit less popular but still available. It's an in-memory object store, and the cache this time doesn't survive the reboots, and the use case are to do a quick retrieval of objects from memory and to cache often access objects. To be honest, and I did my bunch of research, Redis is now largely growing in popularity. It is the dominant cache technology, has a better feature set than Memcached, and overall is going to be the #1 choice. But Amazon still called Elasticache. So personally speaking, if I need to do caching, I will use Redis and not Memcached. But that's a personal preference. The LBS exam will never ask you if Redis or Memcached is better or a better fit. Just know that Elasticache in general is a cache, and just know about the use cases, okay? This was just me giving you a small insight into the technology you should use. So that's it for Elasticache. I hope that helps, and in the next lecture, we'll just go ahead and quickly go through the setup of Elasticache just to see how it works.